Yes, I'm audible. So in the last lecture, we have started the series in parallel combination of capacitors. We did series combination of capacitors and series combination. What is same, Hishma? In series combination, charge stored in each capacitor is same or voltage is same?
Voltage.
Series, voltage is same. Mazia? In series combination, charge is same or voltage is same across each capacitor? Minashi?
The charge.
Charge is same. In series, there is no branching, so charge will remain same. In parallel combination, voltage is same. So we did a very basic question on series combination. We finished parallel combination the last class. We'll do one basic numerical on parallel combination. The question is, today we'll finish this chapter. You have two capacitors, one of 5 microfarad, another of 10 microfarad. They are connected in parallel to a cell of EMF 10 volt. Calculate first part. Equivalent capacitance. Second part. Total voltage across the circuit. Third part. Total charge. Fourth part. Voltage across each. Fifth part. Charge stored in each capacitor. And sixth part. Energy stored in each capacitor. So 5 microfarad and 10 microfarad, they are connected in parallel. So the C equivalent will be, Saifullah, how much will be the C equivalent for the combination?
C1 plus C2. Like
C1
and
plus
C1.
If they are connected in parallel, then C equivalent is just C1 plus C2. So that will be 5 plus 10, which is equal to 15 microfarad. So if you want to convert this microfarad into farad, Mehraj, how will you convert this microfarad into farad?
Into 10 to the power 3.
Minus 6. It's micro. Second part. I need total voltage across the circuit. So what is the total voltage which is across the circuit?
10.
10 volt. So the total voltage across the circuit is 10 volt. Third part. After total voltage, I need total charge. Only how to calculate this total charge? Total charge stored in the circuit.
Sir, charge would be total equivalent capacitance into 10.
So total charge is its equivalent capacitance multiplied by V naught. So how much is C equivalent? C equivalent is 15 into 10 raised to the power minus 6 into voltage, which is 10. So that's 15 into 10 raised to the power minus 5 coulomb is the total charge. Next, I want voltage across each capacitor. Mazia, what will be the value of voltage across each capacitor? Say you have two capacitors connected in parallel. What is the voltage across each capacitor? Mazia. Mazia, you're not audible. Good, Noah. Mazia, what is voltage across each capacitor? Mazia, you're not audible. I can't hear you. Can you just write in the chat room? Please write in chat room. Voltage across each capacitor. Good. So voltage across each capacitor will be same because both are connected in parallel. In parallel, the voltage drop across each capacitor remains same. V1 is equal to V2 equal to 10. Fifth part. Charge stored in each capacitor. Now I need charge stored in each capacitor. Anshika, how to calculate charge stored in each capacitor? These two capacitors are connected in parallel. I know voltage across both the capacitors. I know equivalent capacitance. How to calculate charge stored in each?
Sir, equal capacitance into the potential.
But that will give the total charge. Huh? Equivalent capacitance into potential will give the total charge. I don't want total charge. I need charge in each capacitor, like charge in capacitor C1 and charge in capacitor C2. Arpit, will you try? What will be the value of charge stored in C1 and charge stored in C2? Miraj? A straightforward thing. Hishma?
C1 into voltage.
Yes. See, the charge stored in each first capacitor will be C1 V1. So how much is C1? C1 is this 5 microfarad. So 5 into 10 raised to the power minus 6 multiplied by V1, which is 10. So it's 5 into 10 raised to the power minus 5 coulomb. Similarly, you can calculate charge stored in second capacitor, which is C2V2. How much is C2V2? C2 is this 10 microfarad. So it's 10 into 10 raised to the power minus 6 into V2. V2 is 10. So it's 10 raised to the power minus 4 coulomb. After this, I need energy stored in each capacitor. Anshika, how to calculate energy stored in each capacitor? Energy stored in C1 and then energy stored in C2. Anshika. Arpit. Yes, Anshika. Sorry, Anshika.
I don't remember it.
Don't remember formula for energy. Arpit. How to calculate energy in C1 and C2? Noah?
So U1 will be equal to half C1 V square and U2 will be equal to half
C1 V1 square. Good. C1 is 5 microfarad. V1 is 10 square. Similarly, you can calculate U2, which is half C2 V2 square. And your total energy will be, it's U1 plus U2. That's it. So for series and parallel combination, remember, in series combination, there is no branching in the capacitors. Capacitors are connected such that there is no branching in the system. In parallel combination, the capacitors are connected end to end. Voltage across each capacitor is same. They are connected end to end. Note it down. Now we'll do some numericals of NCERT. Arpit, are you in class? Arpit. Yes, is it clear? Mazia, any doubt in this question? Okay, after this question, the next is, we'll do one question from NCERT. Yeah? So from now onwards, whatever circuit you will do will be a combination of these two circuits. Either that circuit will have capacitors in parallel in this way, or you will have this circuit. This one, sorry. This circuit. So all complex circuit can be divided into small parts having series and parallel combination. Like this particular example of NCRT. See, this is the question. Obtain the equivalent capacitance of the network connected to a 3-volt supply. 300 volt supply means this is the cell, this is the higher terminal, and this is the lower terminal. C1, C2, C3, C4. I need equivalent capacitance of the circuit. First of all, I need C equivalent. For C equivalent, Yashika, can you decide which of the capacitors are in series and which one of them are in parallel?
So 200 and 200 are in series, and 100 and 400, like 200 plus 200 is in parallel, and 100 plus
no.
400 and 100 equivalent is in series.
No. See, in a complex circuit, it's not necessary that all capacitors are either in series or in parallel. Many times, capacitors are neither in series nor in parallel. So just try to pick those capacitors which are in series or in parallel. So as Yashika says, C2 and C3 are in series. You can pick these two. But this C1 and C2 have no combination. They are neither in series nor in parallel. This C1 and C3, no combination, neither series nor parallel.
Sir, will they not be included in the circuit?
They will be included in the circuit, but we can't solve the entire circuit in one step. We'll be solving circuits in steps that we'll be making step-by-step sub-circuits of the system. C1, C4, all are the part of the system, but they are neither in series nor in parallel. Only C2 and C3 are in series in the first step. So what we will do, we will take C2 and C3 are in series. We will be taking the series combination of C2 and C3. So if C2 and C3 are in series, then we can write, we can take it series combination. C12. What is the formula for the series combination of two capacitors, Hishma? Hishma. Formula, shortcut method for the series combination of two capacitors. No, we don't add in series.
By C1 plus C2.
Formula is this, C1, C2 by C1 plus C2. Whereas we add them up when they are in parallel. In series, we don't add them up, we just multiply them. So it's 200 multiplied by 200 divided by 200 plus 200. So this will comes out to be 100. So the C12 is 100 picofarad. Next, what we can do is we can remove this C2 and C3, not C1 and C3, sorry, C23 now. This is C23. C2 plus C3. C2, C3 divided by C2 plus C3. That is C23, which is 100 picofarad. So in the next step, what we can do is we can remove this C2 and C3. Like in this circuit, make a sub-circuit. This is C1. Remove C2 and C3 and replace them by a single capacitor, which is C23. Then take this capacitor C4. And then this is the cell of 300. So that was the first step. Now, Minashi, can you decide which capacitors are in series or in parallel?
C1, C2, 3 and C4 are in parallel.
Okay. Saifullah, is Minashi correct? C1, C2, 3 and C4 are in parallel?
Yes, sir.
Muneeb?
No, sir. C1 and C2, 3 are in parallel.
Yeah. See, C4 is not in parallel. For parallel combination, capacitors should be connected end to end. They should be connected end to end. So see, C1 and C23 are connected end to end. So C1 and C23 are in parallel. But this C4 and C23 are not connected end to end, right? They're not connected end to end. There's no connection. For parallel combination, there should be this type of connection between C23 and C4. But in between C23 and C4, there is a cell. So they are not connected end to end. So C1 and C23 are in parallel, but C4 have no combination. So you can say that C1 and C23 are in parallel. So what you can do is you can just remove them and you can make a single capacitor C123, which is C1 plus C23. So C1, how much is C1? C1 is 100 and C23 is also 100. So it's 100 plus 100, 200 picofarad. So this is 100 and this is also. Next, what we will do is we will remove these two capacitors and replace this combination by a single capacitor. So we'll remove them. When I remove them, I write this as C123 and connect it with a single capacitor. It's 10 volt. And how much is C123? C123 is 200 picofarad. Next, what we can do is, and there is, sorry, not this, just C123, sorry. So we remove them, we represent them by a single capacitor C123. With C123, C4 is connected. And this is the cell, cell of 300. Okay. Mazia, can you decide now what type of combination this C4 and C123 have? C4 and C123. Hishma. Hishma. Or Mazia. Noah, the type of combination that C4 and C123 have?
The series.
Series, right? There is no branching. These two are connected in series. So C, how much is C4? C4 is 100 picofarad. So you can write that C equivalent is C4 multiplied by C123 divided by C4 plus C123 now. So C123 is 200. C4 is 100. 100 plus 200. So that will be 200 multiplied by 100 divided by 300. So this 100 will be cancelled. This 100 is 200 by 3 picofarad. Clear? 200 by 3 picofarad. This is C equivalent. After C equivalent, what you can do is you can calculate. The first step is to calculate C equivalent. Note it down. Then we will calculate the charge and also the voltage. Note it down. Note this question. Simula, Uneeb, any doubt in this calculation?
No, sir.
No, sir.
Can I scroll it? Yashika, Noha, Anshika, written?
Yes.
Safula,
Yes, sir. Done.
Mazia, Miraj, written? Raj. So that is C equivalent. Huh? This is the value of C equivalent. Okay. After the C equivalent, you need total charge in the circuit. Total charge. Anshika, how to calculate total charge in the circuit? Anshika, how to calculate?
C equivalent into voltage.
C equivalent into voltage. How much is C equivalent? That's 200 by 3, right? Pico means 10 raised to the power minus 12. How much is voltage, Anshika? Across the circuit, total voltage across the circuit?
At 300 volts.
300 volts. So if I cancel it out, it's 100. Then the total will be 2 into 10 raised to the power minus 12 plus 4. So minus 12 plus 4 is minus 8 coulomb. That is the total charge. This is the total charge stored in the circuit. If I have the total charge, then what is the voltage across each? How to calculate the voltage across each capacitor? This is series combination of two capacitors. Total charge in the circuit is 2 into 10 raised power minus 8. What about charge stored in each capacitor? Raj? Total charge in the circuit is this. How much is charge stored in each capacitor? Charge in individual capacitors. Inashi?
Same. It will be same.
It will be same. Now, see, this is series combination of two capacitors only. This is circuit. This circuit, this one. Series combination of two capacitors. These two capacitors are in series. Now, this charge will be same. Charge in 1, 2, 3 is equal to charge in 4, which is equal to total charge, which is 2 into 10 raised to the power minus 8 coulomb. This is total charge stored in each capacitor. Then how to calculate voltage across each capacitor? How to calculate voltage across each capacitor? Voltage across each capacitor. I need voltage across 1, 2, 3 and voltage across V4. Yes, voltage across V1, 2, 3 is charge stored in 1, 2, 3 divided by capacitance of 1, 2, 3. Charge stored in 1, 2, 3 is 2 into 10 raised to the power minus 8. Capacitance of 1, 2, 3, how much is C1, 2, 3? It's 200 picofarad. Pico means 10 raised power minus 12. So this will be 2 into 10 raised to the power. See, when this minus 12 come to numerator, it will be plus 12. It's 10 raised power 4 by 200. So that's 100 volt. V4 will be Q4 by C4. How much is Q4? Q4 is 2 into 10 raised to the power minus 8 divided by C4. How much is C4? C4 is this 100 picofarad by 100 into 10 raised to the power minus 12. So this is 200 volt. So we have V123 as well as V4. Now this V123 is further the C123 is the combination of C1 and C23. Just break it down. This is C1 and C23. C1, C23. What is the value of C1? C1 is a capacitor of 100 and C23 is also 100. It's 100 picofarad. C23 is 100 picofarad. And the total voltage across this combination is this V123, which is 100. So, Anshika, now can you decide what will be the voltage across C1 and C23? The voltage across the combination is V123, which is 100 volt. What will be the value of voltage across C1 and C23? Anshika? Okay.
Like for C1, we can calculate it like 1 by 2 C1 into.
No. You are not. I'm not asking energy, Anshika. I'm asking voltage. See the combination of this is C1 and C23, the parallel combination of C1 and C23. Across this parallel combination, voltage is 100 volt. I'm asking the voltage across the individual capacitors. C1 and C23. I need V1 and V23.
It will be same because it is parallel.
Yeah, it will be same because they are in parallel. V1 will be equal to V23 will be equal to 100 volt. Now, what is C23? Minashi, C23 is what combination of which two capacitors?
Series.
Series of which two? C2 and C3, yeah?
Yes.
C2 and C3. This is C2 and C3. And the voltage across the combination is V23, which is equal to 100 volt. Unib, they are connected in series. In series, voltage remains same or it divides?
Sir, it divides.
It divides. Total voltage is 100 volt and both the capacitors are equal. So voltage will divide equally, right?
Yes, sir.
So what should be the voltage across V2, C2 and C3?
Sir, किसके C2 और C3 के ना?
The total is 100. C2 and C3 are equal. In series, voltage divides. Then what should be the voltage across C2 and C3? Noah?
दोनों में 50-50 divide हो जाएगा.
Yes, 50 volt and 50. They are connected in series, so voltage will divide equally. 50 volt and 50 volt. That is the voltage across each capacitor. So we have voltage across each capacitor. This is V2. This is V3. If you need charge, you can simply multiply it voltage with capacitance. So this is the question. It's a 3-marker question that usually comes in school exams. Note it down. This is the type of questions that you can get in your exams on series and parallel combination. We'll do a few more questions. Noha, Uneeb, Miraj, Anshika. Is it clear, all steps here?
Yes.
Written? Can I scroll it further? Okay, the next question is, we'll use the concept of plates of parallel plate capacitor. This is parallel plate capacitor, plate area A. Separation between the plates is D. What is the capacitance of this capacitor? Mehraj? Plate area is A and separation D. What is the formula for capacitance? Anshika, what's the formula for capacitance of this capacitor if plate area and separation is given? Yashika?
Sir, A epsilon naught by D.
A epsilon naught by D. Now, this capacitor have two dielectrics. Huh? Half area is A by 2, another half is A by 2. In this region, a dielectric of dielectric constant K1 is filled. And in this region, a dielectric of dielectric constant K2 is filled. You're supposed to calculate the equivalent capacitance. So due to these two different dielectrics, this is one dielectric. This is another dielectric. One is K1, another is K2. So due to two different dielectrics, this will behave as two different capacitors. One is C1, another is C2. So what will be the relation for C1, Minashi? What will be C1?
K epsilon 0 A by D.
K epsilon naught. It's not A. What is the plate area of this capacitor? This
A
one?
by 2.
A by 2. So it's A by 2 and separation is D. Similarly, C2. Miraj, what will the expression for C2? This one. Anshika.
Sir, K2 epsilon naught A by D.
A by 2D. Now we have to decide whether these two capacitors are connected in series or in parallel. So to decide what we will do, we will give charge to plates. I give positive charge to the upper plate and I give negative charge to the lower plate. Now we will see for both the capacitors what type of connection is there. Type of connection means, is positive plate connected to positive of the capacitor or positive plate is connected to the negative. This is one capacitor. See, this much is first capacitor and this is the second capacitor. See, the positive plate of one capacitor is connected to the positive plate of another. Negative plate of one capacitor is connected to the negative plate of another. So if positive and positive are connected and negative are connected, that means the given capacitors are connected in parallel. So if you want to calculate equivalent capacitance, then equivalent capacitance is C1 plus C2. C1 is K1 epsilon naught A by 2D plus K2 epsilon naught A divided by 2D. So you can write this as, this is epsilon naught A by 2D. It's K1 plus K2. So if positive plate of one capacitor is connected with the positive of another, that means your capacitors are connected in parallel. There is one more method to directly decide whether capacitors are in series or in parallel for this particular type of question where plate is given and two different dielectrics or two or more different dielectrics are given. So in question, if area divides, then capacitors are in parallel. If area divides, then capacitors are in parallel. So if area divides, that then capacitors are in parallel. Instead of area, if I give this question in this way, these are two plates, plate area A, separation is D. Now I'm filling the dielectric through the separation, like up to this half separation, I introduce a dielectric of dielectric constant K1, and in the next half separation, I introduce a dielectric having dielectric constant K2. This separation is D by 2 and this separation is D by 2. Again, this system will behave like two capacitors. The capacitance of first will be K1 epsilon naught A divided by D by 2. So you can take this 2 in the numerator and you can write this as 2K1 epsilon naught A by D. Similarly, for C2, you can write this as it's K2 epsilon naught A by D by 2. This 2 will come to numerator and this will be 2K2 epsilon naught A by D. Now we have to decide whether these two capacitors are in series or they are in parallel. So what we will do is, for the first capacitor, I will give this positive charge to one plate and negative charge to another plate. Due to this positive charge, a negative will induce over this side. This boundary, which divides the two dielectric medium, will act as a plate. And due to this negative charge, some positive charge will induce it. So see, negative and positive are connected. If negative and positive are connected, that means capacitors are in series. Or simply, you can decide in this way also, if separation D divides, then capacitors are in series. That's simple. So if area divides, that means capacitors are in parallel. But if separation divide, that means your given capacitors are connected in series. So for series, I can write 1 by C equivalent is 1 by C1 plus 1 by C2. So it's D by 2K1 epsilon naught A plus it's D by 2K2 epsilon naught A. So 1 by C equivalent will be, it's D by 2 epsilon naught A. It's 1 by K1 plus 1 by K2. So you can write 1 by C equivalent as, it's D by 2 epsilon naught A. It's K1, K2. It's K2 plus K1. So C equivalent is, it's 2 epsilon naught A by D. It's K1, K2 by K2 plus K1. So this is how we calculate C equivalent of the system. So these are the two types of questions which involve plates. So if area divides due to the dielectrics, that means capacitors are connected in parallel. But if separation divide, that means capacitors are in series. Note it down and tell me if you have any doubt. Raj, any doubt in these two questions?
No, sir.
Anshika, any doubt in this calculation?
No, sir.
These are the two most important questions on capacitors. When circuit comes in your exam, the maximum possibility of questions is from these type of circuits where you have plates and this dielectric. Aisha, I'm starting with you in just 5 minutes. Just finishing this topic. Okay, with this question, chapter number 2 is over. I'm sharing assignments of 15 questions that will cover mostly of capacitors and some of potential. I will end this class here. From the next class onwards, I will divide that class into two parts. Half an hour, the first half an hour, we'll do revision of chapter number 1 and 2. Particularly, we'll be discussing numericals, which are a bit tough and in the syllabus of JEE and NEET exam. And for the rest of 1.5 hours, we'll be doing this chapter number 3 only. So by the time we finish chapter number 3, your chapter number 1 and 2 gets over. And you can revise that chapter from the point of view of JEE and NEET exams. So this is what we will do from this Wednesday onwards. So I will break this class into two parts, half an hour for JEE and NEET, revision of chapter 1 and 2, so that you don't forget those concepts. And for the next 1.5 hours, we'll be continuing with chapter number 3 only. And this is how we'll do for the entire year. First, we'll finish a chapter, keeping your CBSE thing in mind, and then we will revise it from the point of view of JEE and NEET exams. Those who are not interested in JEE and NEET exams should also join that 30-minute class. It's good. It would be good for your numerical solving skills. We're doing some really good questions. Okay, so I will stop here.
Thank you, sir.
Thank you, sir.
I'm sharing an assignment. I will need that solution in the next class. Before Wednesday, I need that solution. You will have 24 hours to submit that assignment.
Thank you, sir.